Alright, so today we're going to talk about logarithmic functions, but first we're going to talk about how to solve exponential functions. So what we're going to do is we need to take this 36 and make it a base of 6. So 6 to the second power is what gives me 36, so that's going to be what we're going to change that to. And once you get these bases to be same, all you have to do is set their exponents equal. So in this case it would be x equals 2. The next one, 5, so 5y minus 3. Okay, 25, we're going to make 5 squared. So that the bases are the same. So now that the bases are the same, take the two exponents and set them equal to each other. And now it's just solving an equation. Distribute first. Okay. Subtract the 5y from both sides. We're going to subtract the 22 from both sides. Those cancel, so I get negative 25 equals y. Let's do another one. Okay, it says 4 to the x is equal to 64, so 64 I'm going to change to a base of 4. So it's going to be 4 to the third power, so x will equal 3. Okay, and the last one. This base is going to stay with 3, you can't change that to anything, but I can make the 9 a 3 squared. Now that the bases are the same, I'm going to take the two exponents that are equal to each other. Distribute. And we're going to subtract the 2x, subtract the 2x, add the 4, add the 4. 30 is equal to 3x, so x will equal 10. Okay, so those are exponential functions. Okay, but now we're going to explore how exponential equations have all the same base that don't have the same base. Exponential functions are one-to-one functions, therefore they all have an inverse. So we created the table values for 2 to the x power here. And now we're going to do the inverse. Remember, when we do the inverse, you just take your x's and make them now your y's, and make your y's now your x's. So I'm going to rewrite all these. Okay, so now all my x's are my y's, all my y's are x's. Now we're going to graph each one of those points. So it's 1/4 negative 2, 1/2 negative 1, 1, 0. 2, 1, 4, 2. Now here is my function right there. Okay. Notice it's a reflection over the line y equals x. Y equals x. Okay. So consider the steps that we have for inverse functions. Okay. Typically we'll switch our x and y, and then we'll solve for y. The problem is we're not able to do this knowing our current knowledge. So our new notation called a logarithm helps us write the inverse function of an exponential function. Okay? So x equals b to the y is the same as y equals the log base b. So when we write a base in the logarithmic form, it's a subscript to the x. Okay? X has to be greater than 0, and y is a real number. Okay? So it says write each of these as an exponential function. Okay? So here, our base is going to be our base of our exponential function. The number that is equal becomes our exponent. And the number that's over here is now going to come on the other side, so it's going to be 2 to the 4th equals 16. Okay? Try the next one. Okay, again, this base down here, the subscript, is our big base. This is going to become my exponent, equal to the big number over here, which is y. So 3 squared is y, so 13 squared is y, so 13 squared is 169, so 169 is my y. Okay? Now we're going to go the other way. Okay? So it's going to be log The base of the exponential is going to be the base of my thing, but that's a subscript. Okay? This number is going to be the big number over here. And it's going to equal the exponent that's left over here. So logarithm of 125 with the base of 5 is going to be 3. Okay? Next one is going to be the log. My base is 4. So it's going to be sub 4. Okay? Of 1 over 16 is going to equal our exponent of negative 2. We can take these and solve them. Okay, we're going to solve this logarithm function, okay, by converting it back to exponential. So again, it's going to be 2 to the third will equal x. So 8 is going to be x. Okay, same with the next one. We have x squared will equal 49. Okay, take the square root, take the square root. So x will equal plus or minus 7. Well, we said at the beginning, x cannot be negative, so x will only equal 7 in this case. Okay, so here's something to try. So it says write each of the following as an exponential equation. Okay, so here it would be 5 squared equals 25. On this one, it would be 2 to the x equals 8, but I can convert that, so 2 to the x equals 2 to the third, so in this case x would equal 3. It says write each of the following as a log function. Okay, it's going to ask us to convert to log function, so it's log, the base again is the base of the exponential, which is 4. The 64 becomes the big number over here, and it's going to equal the exponent, which is 3. So on this one, this log base is going to be 6. So 1 over 36 is going to equal our exponent, which is negative 2. Okay. These ones we're going to solve. So this one would be 2 to the negative 1 equals x. Remember, that's the same as 1 over 2 to the first, which is equal to x. So x will equal 1/2. The next one, x to the negative 2 is equal to 49. Okay, so that's going to be 1 over x squared, which is equal to 49. We're going to multiply both sides by x squared. Those cancel away, so I get 1 equals 49x squared. We're going to divide both sides by 49. 1 over 49 is equal to x squared. Take the square root. Square root of 1 is plus or minus 1 over 7. But remember, in logarithms, x cannot be negative, so x will only be positive 1 over 7. Okay? So, with these, okay, if I put an x here, okay, it says b to the x would equal 1. Well, if I make that a base, it would be b to the x equals b to the blank. Well, what to any power makes it 1 is 0. In this case, x would equal 0. Same thing, if I made this an x, it would be b to the x equals b to the x. Okay, which is a true statement. Okay, it says in logarithmic equation, y equals log of base b. Can x be negative? The answer is no. And the reason we have that is if I convert that back, b to the y equals x, okay, no matter what I put in for y, okay, if I put negatives in for y, x will always come out as a positive of like 1 over something or something along those lines. Okay? Show the following property is true. So if I converted this to logarithm, the log base b of x would equal log base b of x, this exponent up here. That is a true statement. We're good there. Okay? A logarithm, remember, is just a way to write an inverse for an exponential function. Okay, so it says, given the function f of x equals 3 to the x power, find the inverse. Okay? So if I have y equals 3 to the x, if I were to find the inverse, switch your x and y, so x will equal 3 to the y, and now we're solving for y again. Well, to do that, I have to, since y is the exponent, I have to convert it to log function. So we're going to have log base 3 of x is going to equal y. So there's my inverse. Okay, we're not going to prove it. All right, so we're just going to skip that part. Okay, so let's graph the two. So the first thing we're going to do is graph. The easiest way to do this is to graph your original function, which was 3 to the x power. Okay, graph the original exponential. Okay, remember 3 to the negative 2 is the same as 1 over 3 squared, which would be 1/9. Okay, 3 to the negative 1 would be 1 over 3. Anything to the 0 power is 1. 3 to the first is 3. 3 squared is 9. So I'm going to graph those. We have a horizontal asymptote here. Okay, no, x equals 0. Now, if I wanted to graph the inverse of it, which would be the log base 3 of x. Okay, all these points would switch around. So it would be 1/9 negative 2, 1/3 negative 1, 1 0, 3 1, and 9 2. So let's graph those points. 1/9 negative 2, negative 1, 1 0. 3 1, 9 2, and with logarithmic functions, instead of having a horizontal asymptote, they have a vertical asymptote at x equals 0. Now let's go to another one. Okay, same thing. Find the inverse. So I'm going to start with y equals 1/2 to the x. We're going to switch our x and y around. Because the y is now in the exponent, we have to convert it to logarithmic. We log our base of 1/2 of x is going to equal y. So there's my logarithm function. Again, we're not going to prove it. Okay, then since you graph it, so x and 1/2 to the x. Okay, remember, 1/2 to the negative 2 is the same as 1 over 1/2 to the negative 2, or 2 squared, which comes out as positive 4. Then it goes 2, 1, 1/2, 1/4. Okay, so it goes the other way around. And remember, these are decreasing functions. Okay, still same thing. The inverse of this okay, remember to switch your x and y's. Okay, and notice it's the same type of function, it's still the same direction of these logarithmic functions. Okay. So, some practice problems here. Okay. Is f of x a logarithm, a one-to-one function? The answer is yes. Okay. Because what is the x-intercept of my log function? The x-intercept is going to be at 1, 0. With logarithmic functions, you don't have a y-intercept. There is none. Okay? The domain of the function is reversed, so because of our vertical asymptote at x equals 0, okay, so we're going to go from 0 to positive infinity for our domain. And our range, since it will go on in both infinitely many directions, is from negative infinity to infinity. Okay? So the following are graphs of log functions labeled where b is greater than 1 and the graph where b is less than or equal to 1. So this is increasing. And this is where b is larger than 1. So this one, this is decreasing. And this is when that b, that base, is a fraction of some kind. 0 and 1. Okay? And it says, what is the inverse of the function f of x equals log base 7 to the x? Okay? So if I have y equals log base 7 of the x, switch my x and y. Okay? And to figure this out, I'd have to rewrite it as an exponential. So the base would be 7 to the x power would equal y. Y is now back by itself, so we're good, which is letter